Hello everyone, welcome back again. So in this segment, we are going to learn about one more operation about binary search tree. We're going to see how to insert a new node in a binary search tree. All right, so let's see. So given a tree, let's say you have an already existing binary search tree. Now we want to insert a new node in the tree. So any kind of operation that will update the binary search tree, we have to make sure that after the modification or after the update, the binary search tree still have to be the binary search tree. Means we're going to follow we're going to follow all the properties of the binary search tree with insertion operation. So after the insertion, the binary search tree should remain the binary search tree. All right. So for in the algorithm, the way algorithm works for insertion a new key into the tree. So we are going to always insert the tree as a leaf node. All right. So we're not going to insert in any like as a parent of any other node. All right. So the new tree will be always inserted as a leaf node. All right. So what we are going to do, we are going to start searching a key from the root, all right, until we find a leaf node. Okay. All right, until we find a leaf node and with following the properties of the binary search tree, that's very, very important. So once we find a leaf node, the new node will be added as the child of the leaf node. Okay. All right. So let's see an example. So let's say this is our binary search tree. Okay. So the binary search tree actually looks like this. We have 6, 2, 8, 1, 4, and 3. Okay. So we want to insert 5 in this binary search tree. So we have to find a node, all right, where the 5 can be the children, where the 5 can be the child of that node. And always remember the new node, we are going to insert that as a leaf node. Okay. So we start from the root node. All right. So 5 is less than 6. So obviously 5 has to be part of its left subtree. Okay. So all right. So 5 has to be the part of the left subtree. So what we're going to do, we're going to go to the left. Okay. So we start from the root 6. 5 is less than 6. So go to the left. So now in this left subtree, we find a node. Now 2 is actually, so 5 is greater than 2. Okay. So where should 5 go? So 5 has to be the part of the right subtree of 2. Okay. So go to right. All right. Now we are at 4. Okay. We are here. Now 5 is again greater than 4. Okay. So 5 should be in the part of the left subtree. Okay. So I'm sorry. Let me say that again. 5 is greater than 4. So 5 should be part of the right subtree of 4. All right. So 5 should be part of the right subtree of 4. Now, in this tree, this is actually the tree after we inserted 5. Okay. So in this tree, you can see that we started from 6. Okay. So this is what we are going to insert. So go to left 2. Now 5 is greater than 2. So go to right 4. 5 is greater than 4. Now 4 doesn't have any right children. Okay, 4 doesn't have any right children. So that means I can insert 5 as a right children of 4. All right. So that's why the tree will stay as a binary search tree and I am inserting 5 as a leaf node. Okay. So let's see one more example. So let's see, I want to insert 10. So we start from the root node, okay, and 10 is greater than 6. Okay, so 10 should be in the part of right subtree of 6. Okay, so go to right. So we found 8. Okay, so 10 is greater than 8. All right, so we're going to go to right of 8. Now 8 doesn't have any more right children. Okay, so 8 doesn't have any more right children, so that means we can insert 10 as a right children of 8. All right, so let's see an example, and we want to insert 9 in the updated tree. So the updated tree actually look like this. So now we want to insert 9. So we start from 6. Okay, so 9 is greater than 6, so we're going to move in the right direction. All right, so now we find 8. All right, so 9 is still greater than 8. Okay, so we move to the right. Okay, now we find 10. So 9 is less than 10. Okay, so 9 is less than 10, so 9 has to be part of the left subtree of 10. Okay, now 10 doesn't have any more children, so its left children is null. All right, so what we can do, we are going to add 9 as a left child of 9. All right, so this is the insertion operation. It actually, you can see the traversing, how the way we're traversing the tree is same as like the searching. But for inserting a new node, we are going to always insert that as a leaf node. Okay, so the node we are going to insert. All right, so we searching the key. We start searching the key from the root until we hit a leaf node. All right, so when we find the leaf node, we are going to add the new node. All right, as a child of the leaf node. Okay, as a left child or right child of the leaf node, depending on the value of the node we are trying to insert. All right, now another question, how to handle duplicate values. So for all examples, we saw that actually there were not any duplicate values, and we actually, the way we describe the properties of binary search tree is, we always talked about that, means all the values less than the root node has to be in the left subtree. All the values in the right, all the values greater than the root node is going to be in the right subtree of the root. All right. All right. Now, what if we have a duplicate values? For example, what if I want to insert 6 in this existing tree? Okay. All right. Um, so that's actually an open question. So there, if we have to have a duplicate values in our data structure, so we have to actually find a way in our binary search tree. Okay. Now, I want you to also think about it, and I'm going to talk about that also in the next class, but I want you to think about it. Okay. But just remember like that. So when we have a node here, so all the binary search tree property says that all the values, okay, in the left subtree has to be less than the root node. Okay. And all the values in the right subtree has to be greater than the root node. Okay. Now, what if we find a value that is same as the root node? That is an open question. And let's see. So what you can do, actually, I will ask you to try to insert a duplicate value in a binary search tree. For example, here we have already 2. Try to insert 2 here. Okay. And then let's see what happens. All right. And how do you want to insert them, or after you insert it? Okay. So how do you want to find them? All right, so we're going to talk about more in our next segment. Now let's see, we want to see, that's our last discussion for this segment. We want to see the algorithm. and for the insertion. All right, and here we are going to also talk about the iterative solution, because we talked about the iterative solution, how to find a node in the binary search tree. And here also we're going to use the same approach, but we'll find them, we're going to keep searching. We're going to implement the searching algorithm until we find a leaf node. Okay, all right. So here you can see that we want to insert this data in this binary search tree. All right, so first we're going to check that. So first we're going to create a binary search tree node using this data. All right, all right. So first we are going to check that whether the binary search tree is empty or not. So if the binary search tree is empty and we want to insert a node, that means we are going to insert the node as a root node. Okay, so for example, you want to insert a node 6 here and you have completely empty binary search tree, so no node, no tree yet, so we are going to insert 6 as a root node. All right, now if not, then if the tree is not empty, then obviously we're going to have a current node. Okay, so let's say this is our root, and we are going to have another current node that will actually traverse the whole tree. All right, so we are going to initialize the current as the same as the root node, means current will point to the same node as root is pointing. All right, all right, so we start from here. All right, and we're going to actually find it like that. If node, the data is greater than the data of the current, the data that we want to insert is greater than the current, we are going to go to the right, else we are going to go to the left. Okay, all right. So this way we are going to actually reach to any one leaf node. Okay, so here we are assuming that we are not actually here handling any duplicate values. Okay, now at this point, I mean, by this traversing in this while loop, we're going to reach to any of the leaf node. All right, then here we are going to check, let's say we reach to any leaf node. All right, so then we are going to check the value of the data with this value of this leaf node. Okay, if it is smaller than this, we are going to set that as a left node, else if it is greater than this value, then we are going to set that as a right node. Right, all right. So all right, so that's in this segment we're talking about the insertion operation, and we have couple of other operation we want to talk about. We're going to talk about deletion operation, and then how the traversal looks like in binary search tree. All right, and finally we're going to talk about the runtime of each of the operation. All right, all right, so thank you everyone, we'll see you in the next segment. Okay, bye.